Hello, good evening, everyone. So, everyone, please join and wait. We'll start the session in 5 minutes. Okay.
Hello, sir. Are you there?
Starting now. Okay. Good evening, everyone.
Good evening, sir.
Yeah. So, today we will be looking at the entire notebook for customer churn prediction. And if the time allows, we will also look into the fashion minst classification. In the lecture, Sarah has just touched upon the training loop and etc. So we will look into how each of the functions like EDA, how is being done, how feature engineering, then how a model is trained, the entire process. Okay. So this is the agenda for today. Uh,
Uh, Sir, you will also for a
yeah,
pre-processing part in the lecture. The sir,
yeah.
professor.
We especially will work on the pre-processing part because that has not been covered. So we'll look into it. Okay.
Okay, sir.
Can we code along with you, Puneet, or
I don't
suggest?
think so. It would be easier for you if you understand it right now, because what I'll do, since I was just going through the notebook and the notebook is quite long, so there are many components for it. So if I start writing everything, then it will take a lot of time. Even we won't be able to do EDA in 2 hours. So
Okay,
I will,
okay,
yeah, I'll copy those things. What are the relevant parts? I'll copy it to this notebook, whatever is sharing right now, and I'll share this with you guys. So you understand it here right now, and then later you try to run those things, or maybe you can try to write those things as well on your own. So that would be a better alternate, I think so.
okay, okay. We'll follow, and
Okay.
then we can stop you in between, or you
Yeah,
want
yeah.
we'll.
Anytime you have any doubt, or if you feel that I'm skipping anything, feel free to stop me there itself.
Okay,
Okay.
okay. Thank you, thank you.
So, what will be taught today? The topics and analysis.
So I am planning that the both customer churn prediction and fashion mince classification problem, both of them, if time allows, to cover both of them today in depth. Whatever processing, pre-processing, EDA, feature engineering, model training, all those steps to should be covered. I'm trying for that, aiming for that. Okay.
Okay, the programming part of that.
Yeah, programming part. Yes.
No theory today.
No, I think so. Pulkit has covered most of the important topics that needed to be done like back propagation and forward pass. So we'll start with coding today.
Zor wasn't done. Oh, okay, okay, sir.
Okay.
Understood.
So we
Okay,
have
sir.
more sessions this week now. So instructor sessions are also there. So I think
Yes,
so
yes,
that
yes,
might get discussed there.
yes, yes.
Okay. Okay. So let's start. So we are first working on the customer churn prediction. Okay. So I'll just give a heading to it. Hmm. Okay. So first thing is we have to import the essential libraries. So we have pandas, we have numpys. We'll be using matplotlib and seaborn for visualization. Then there are some things that we'll use for deep learning. So we'll take those imports. So first of all, we get the torch library, PyTorch, and we have from the utils data, we have a data loader and tensor data set. This will be used when we upload a CSV file, and that CSV file has to be uh, cut into like xtrain, ytrain, and then xtest, ytest. And then we will use a data loader kind of object. So from there, we will be loading the entire data set. From sklearn, if you guys have studied MLP, you would know this, that sklearn has this train test split that takes input the features and the labels of the entire data set, and it will cut it into two pieces, like xtrain, ytrain is at one hand and xtest, ytest in whatever ratio that you specify. Then we are using stratified k-fold strategy. Why this is being used? Because the data set that we are using, as you will see after some time when we do the its EDA, then you will see that the data set is quite imbalanced. So for imbalanced data set, we have to use a stratified strategy so that the class imbalance problem gets solved. Okay. So after that, we have from pre-processing, we are using this standard scaler and label encoder. Standard scaler means we will be applying the scaling technique for normalization. So whatever our numerical values are there, so we'll try to give them a boundary. So I think so. The boundary for standard scalar is 0 to 1, if I'm not wrong. And for the categorical variables, we will use label encoder. What is label encoder? Basically, label encoder is a shorter version or compact version for what is one hot encoder. So these two are major encoding techniques that we generally use to encode the categorical variables. So label encoder is like, let's say in your data set, you have like a column which says like which has four rows. Okay, let's say it is the names of the animals. So it will be like dog, cat, again dog, and let's say sheep. Okay, so we assign a unique value, unique numerical value to each of this. So let's say we assign dog as 0. So dog is 0. Then cat is, let's say, 1. But dog is again there. So we'll take the first that we used, right? 0. So 0, 1, 0, and sheep will be assigned 2. So in this way, label encoding is done. Next, from the classification metrics, we take classification report, confusion matrix, ROC under area under the curve, ROC score, then ROC curve itself, precision recall curve that gives you the trade-off between the precision and recall. Based on precision recall, you can also calculate the F1 score, precision score, and recall score. So these are the types of metrics that we will be using for estimating whether our model is good or not. Okay. And finally, we have this class weight that helps to compute the weight. Okay, so that will actually help you in the imbalance part. And finally, you will use this stratified k-fold strategy to resolve this problem of this class imbalance data. Okay, so we have done this part.
Punit, can you just go a little bit up
Yeah.
from 6 to 10 and then 16?
Hmm.
These are all new. The
This,
starch and the torch is completely new.
yeah.
What are all the things that what are all the in what form it helps? What are the features or how it helps? Because
So
the things are all
torch is
experienced.
basically, yeah, torch is basically the entire PyTorch library you are importing first of all. Then you are calling this NN, that is neural network. So because you have to train a model and you have to train a model from scratch, for that you need the neural networks.
Neural
Uh,
network is under torch. Okay.
yeah.
Optim.
Optim is the optimizer. Like you would have studied somewhere, like there are optimizers like Adam, Adagrad, and all these optimizers that will help you to optimize while you are doing the forward pass and back propagation, so that you have to optimize the weight. Okay, so everything is the play of the neural network is you have to optimize the weights as much as possible, right?
Mm, mm, mm.
So for that, Optim module is there.
And
Okay.
functional.
NN.functional is just another component of neural networks. We will see when it is being used.
Okay. And this
Okay.
class weight is again class. Okay.
Class weight is computes the
That's
class weight for you
that's
easily.
okay.
Otherwise, you have to do some amount of coding to understand the class
Yeah.
weightage. And then you have to use this stratified k-fold strategy that will help you to handle this imbalance problem.
Okay. Thank you. Thank you.
Okay. And now we have to set the random seeds for reproducibility. So I have set, okay, I have not run this. Hmm, it is being run. Okay. We will be using random seed 42 for NumPy as well as for the torch. We have, and we are not, I'm not turning on the T4 GPU because I think so this should, customer churn prediction can work in normal CPU as well. But for especially for the fashion minced classification, I would suggest that you guys should use T4 GPU because it is an image training, and image training requires a lot of things. Okay. Okay. Uh, yeah. Okay. So now we have, I'll just upload the data set that I have with me. Okay. Hmm. Okay. We have this data set. So I'll say df is equal to pd dot read underscore csv. Now we have to specify the path for this. Specify the path. Now I have the data set with me. Okay. This is the same data set that was used in the lectures. So it is not different. Okay. Okay. So now we have to first let's see what is the print df dot shape. Print we need the memory, so we'll use def dot memory usage. Hmm, okay. We need to see how much memory it is occupying. Then we have to see what is the first 5 rows that is required by us, and yeah, uh, we'll take an info df also. So this will tell you, see what we are telling you, that column in this data frame, df dot columns will return how many columns are there. Then for each of the column, what is the data type that is being used? How many non-null values are present? How many null values are present? If you don't want, you can remove this. This gives you the null percentage. So we just have to remove this null percentage. And what are the unique values in each of the column? So we'll get this. Okay. Yeah. So first run this. Okay. So it tells you that the shape of this CSV file is 7043 rows are there and 21 columns are there. This is approximately 7 MB that is occupying. Okay. This is the memory usage it tells you. Then you have the df dot head. This is the df dot head. It is giving you the first 5 rows as per the rules. Okay. And this is the important part. Okay. Info df that we have printed. See, for customer ID, you for like each of these columns, 21 columns, it tells you what is the data type. Now you will see that there are some problems. Like you see this total charges. Total charges is an object, which is not good. Total charges should be an integer. So in this way, you will understand while doing the preliminary analysis itself. This is a part of we are just loading the data set, and we are just brushing past the entire data set to see what are the things that are problematic. Okay. So there are some, so the non-null count, it is saying 7043, but you will later see that there are some errors in the CSV file. So we have to see, okay, is this much fine? This much fine?
Yes, sir, it is okay.
Okay, so it tells you that the non-null values are 7043 and there is no null values, but this is not true. We will see later why it is happening like this. Okay, and it tells you how many unique values are there. Okay, so let's move ahead. Okay, so moving to the next part, we have to check the target variable distribution. Okay, so what we will see, we have this churn values, and I'll just print the, sorry, every part should be component different. Print churn percentage. Yeah. So you see the churn values. No means that the customer didn't go, and yes means that customer went away. So it is approximately 73% is no, and yes is 26%. So you can show that this is a quite a huge disproportion. Okay. So we have to handle this sometime. Okay. There is one more thing. There is something called as class imbalance ratio. So class imbalance ratio will come from this churn count only. It is basically, so first of all, you take the min value of this churn count, whatever churn values are there. You take the maximum value, and then you do the imbalance ratio is majority class upon the minority class. Okay. So
Churn counts as a series.
Yeah, it is a value count. No, yeah, it is basically yes and no.
Okay.
How many yes values are there? How many no values are there? It tells you that. Yeah. So it tells you the class imbalance ratio is 2.8 is to 1. That is approximately 3 is to 1. So as we could see from here also, the no is 75% and yes is approximately 25%. So it is based on that. This is a kind of a small metric that we have checked, class imbalance ratio, to check what is the class imbalance that we are facing here. Okay. Okay. Next is we if we want to get the basic statistics for the numerical columns. Okay. So we'll take this and with this we have print and we'll print df numerical calls dot describe. Yeah. So we get for senior citizen tenure and monthly charges. As per this, you see, there are senior citizen is a data type which is of integer 64. Tenure is of integer 64, and finally you have monthly charges of float 64. Otherwise, there are some things like you see total charges, paperless billing. I don't know what this is. We have to see what this is. But obviously, the total charges should have been an integer value, which we don't have. So we'll see how to fix it later. But from the initial data type, you can see there are only three things: senior citizen, tenure, and monthly charges that are present in the integer numerical data type. So from here we can see that df.select data types includes the np.number. np.number means check for the column whether that column is has a number like a numerical value, and then you are converting it into a to list. So you have converted this into to list. Now, if obviously customer ID, we are removing it. We don't need the customer ID because each of the customer IDs are unique. So from 1 to 7043, all of the values are unique. Okay. So we have removed it. And then finally, we apply the describe function on these three. And when you apply the describe function, it gives you an initial statistical analysis. Like it will tell you how many values are present, what is the mean value, what is the standard deviation, what is the minimum possible value of this column, and then you have 25%, 50%, and 75% quartiles, and finally, what is the maximum value that is possible. Okay. So any doubts till this part?
Sir, we can also use pandas.describe function here.
Yeah, this is that only, no? So I have converted the entire CSV into a data frame using pandas only. And on pandas, I am applying this describe function.
Okay.
Senior
Actually,
citizen 0 and 1 refers to yes or no type. What?
Uh, we will see. I have also not seen what the data set looks like. We will explore how it goes. Okay.
Sir, can you scroll the screen a bit up, like,
Uh,
sir, a bit more.
what
Sir,
do you want?
sir, how did you like read that? Okay, sir, this file is like available in the portal, right?
Yeah,
Like,
yeah. See, this is the CSV file.
okay, sir.
Okay.
Okay, okay.
Yeah, this is available in your, if you go into your portal and supplementary content, then you click on that week one folder. Inside that, this is present. The CSV file is present. Okay. Yeah. So we have seen what the numerical columns look like. Now we have to see what are the categorical columns with us. Okay. So we'll take that code snippet. Okay. Hmm. Yeah. Just a minute. Hmm. Yeah. So now I'll just run this first. Okay, so it says that from the entire data frame, select all those data types that includes an object. So you see, whenever this was present, it if it is a string or any other thing, no? So it will give you an object data type on the pandas. Okay, so we are taking this whenever this data type is object. We take all those as categorical columns and again convert it into a list format. If there is a customer ID available, then you just remove it. Okay, now what I am doing that, okay, so I should actually remove this for all of them. And now if I do this, yes, very good. Yeah, I should remove this part. Hmm, yeah, very good. So now what I'm saying is for each of these columns, what you have to do, you have to bring me what are the unique values. Okay. First of all, you tell me how many unique values are there. So that is the count of unique values. And you also tell me what are the unique actual values. Okay. So gender, we have two unique values, female and male, partner, yes, no, dependents, no, yes, phone service, no, yes, and it goes on like that. Okay. Now, at least things like if you see yes and no can be encoded, but you see there is some problem. Like it says multiple lines. There is no phone service, no internet service. So we have to fix these things. Okay, so we will fix it later. And total charges, it shows that it has 6,531 unique values. But now you see, as I was telling you, these should be an integer value, but it is not so. It is a string. You see, these quotes are there, which makes it a string. We have to convert it later on. Okay. And churn has two unique values, no and yes. So for that only, we have brought that label encoder that will help us do this part. Okay. So with this, we have done our initial data loading and like inside gathering process. Okay. So I'll just write it down here. Um, Here we have imported the libraries. And then we load the dataset and initial insights gathered. Okay. Yeah. So we have done the importing libraries. We have loaded the dataset and we have seen what kind of values we have, how many values are these things we are now clear. Any doubts till this much?
Sir, seeds or manual seed, what difference?
One, I am setting the manuals, I'm say putting the seed for PyTorch library. Another one I am setting it for NumPy library because both of them requires this.
Okay, sir.
And this memory usage, why we check?
Just to know how much memory my data set is using, because there might be times when you will see that your data set size itself increases like in GBs. So during that time you have to do something known as streaming. Otherwise, even keeping your data set with you will be a problem at one point of time. So we have not seen those type of examples yet, but they do exist. Okay.
If it is, how many GB we have to do streaming? Greater than how many GB we have to do?
What?
Or
Sorry,
is there
I
a
am not
specific
able to.
size? It is already there. That after this size, better to do streaming or something like that.
No, there is no such thing. It depends on your RAM. How much RAM ability do you have?
Okay. Okay.
Yeah. It is a personal
Yeah. Yeah.
like
If I have
decision that
more
you have to
memory, I
take.
can do normal way. Otherwise, I will do streaming.
Huh. Okay. So we have loaded the data set and we have the initial insights ready with us. Okay. So next thing is that we will do is data quality assessment. Okay. Why it is? I removed it now. You delete and hidden. Very good. Text. Oh, okay. Now I understood. Data quality assessment. And we will do a little cleanup also. So little cleanup. And now we get the new cell. Now this should go back. Hmm. Yeah. So now we are in the data quality assessment. Okay. So for now, what we will do, we'll create a copy of this data frame and keep it in the save it in a new variable called df clean. Now we will use this df clean only to do all my like analysis kind of thing. Okay. So as let's say we'll just print original for shape. Okay. Yeah. So we'll just see this. Yeah. So initially we have 7,043 rows and there are 21 columns with us. Now we will see what are the things that we remove and what are the things that we keep. Okay. So first thing that we want to know is the number of duplicate customers. So code, so print duplicate customers. So what I'm doing is, so we already know that customer ID is the only column with us that should not be duplicated. That is the ideal situation. You want that each of your rows should have a unique customer ID. Okay. So we will check with that column itself whether we have any duplicated values and we'll take a sum of it. So it tells you that there are no duplicate customers. So at least one problem is solved. So from here, what we gathered that we don't have any duplicate rows. Okay. Next part, we will handle the total charges. If you remember that the data type of our total charges was object. We don't want that. Okay. So I'll just print the current version, what is currently we have. So we current data type is total charges is this object, right? And we want this to be an integer. Okay. So yeah, so we have the data, we have the code for that. Yeah. Hmm. Just let me see whether we need it or not. Hmm. Okay. Yeah. So we are saying, I'll just print this also, print non-numeric count. Yeah. So I'll just print this 11. So it says that df cleaned total charges. What I'm applying is this is a function. This is a lambda function. If it is not a string, uh, then you have to replace this dot with whenever if there is not a string, then you replace this any dot with a empty string and again replace if there is a space there. Just convert it into a empty string and finally you convert that into a digit. Okay, and then you give me the total number of non-numeric count. So there are some values that are, most of the values are numeric only that you saw, like 21.85 and those kind of examples. But there are some non-numeric things also. So we have taken the account for them. And finally, what I'm saying that now you have to convert this into a numeric form. So I'll just convert this and we don't need this now. The initial data type was object. Now we have df clean total charges. We are saving it in the same place itself. Okay, we are this is an in place is equal to true kind of thing. Okay, so we have taken that cleaned total charges wherever there are errors. So you have to, yeah, I'll just raise coerce. So if there is an error, you have to just raise an exception. Otherwise, just convert them. Okay, and now what we will do, we will print the data type once again. Okay, after the conversion, we have not yet converted it. After the conversion, what is the data type? Now you see it is a float 64 object. So we have handled the non-numeric values, we have handled the entire numeric values which was present in string, and now we have this total charges column as a float 64 object. Okay, any doubts so far? I hope everything is fine. Yeah, Gaurav.
So why would we take out the point as well? Because some values are float, so like
No,
it's about
this
29.
means This
what?
means there are some values where there is no value given. You are just given like this.
Okay.
Yeah. And this means that there was an empty string. No value was given to it. Now, see, handling the missing value is a separate issue. We will do that later. But first of all, everything should be converted to a standard string. And then from once what we have done here is we have converted everything into a standard string. And once we have the entire string thing, then we have removed the string part and converted everything into a numeric value. Now, what will be the value of the empty string? It will be 0. Okay.
Okay.
And sir, what is that errors code C?
Yeah. If there is an error, it will help you to raise an exception against it. If you don't keep it also, there won't be an issue for now, but it is a good practice.
So for non-numeric counts, how does this error will handle?
We have already converted into a digit, no?
But what about that non-numeric counts? 11 were there, no? That are
Yeah.
not
So
digit.
we have converted it. In this apply, we have applied a lambda function. We have
Oh,
converted
okay.
into 0.
Okay.
Now it is a missing value problem. We will handle it now in the next step.
Puneet, I just have one doubt. This is customer churn we calculated, right? Before
Hmm. Hmm.
there was a ratio, right? Yes versus no,
Hmm.
something like that. And then after that, you try to see the customer ID, any duplicates. There is no duplicates. I
Hmm.
don't understand this. Yes and no, and then no duplicates means I don't understand that.
Oh, churn is a separate thing. Churn is a label format. These are the
Oh, this
features.
is a separate column, and
Ah, yeah.
uh-huh. How the
See,
because if
leave everything, leave everything. Let's take an example of this class. There are 34 members right now. Okay. So most probably that entire 34 members this is list is showing are unique, right? So how will you identify it? We have a roll number. Each of us have a roll number. With that, you can say that that this person is unique. But if I ask you, what is the what are the different classes that are possible in this class, and
oh,
I'm
okay, I got
categorizing
it.
them.
I
You are a
got it.
student, I am a TA.
Okay, there is a customer ID is one column and
Ah,
churn is another columm.
ah,
And wherein this customer ID is yes, they have given some customer ID, they have given no, something
ah.
like this.
Yes.
Okay, I got it
So
wrong.
customer churns means I
Okay,
ask.
there is a column for churn and then every ID. Okay, there is no repetition
So
is fine.
there are 73% of the customers that are
Yeah,
churning,
yeah.
and no, sorry, 26% are churning, but 73% are retaining. That is not churning.
Okay, okay, okay. And then this replacement, you can just explain a little bit because I don't understand. Two times we do that replace
Yeah,
function.
because this is not very good practice, because I know already that sir had knew already that these kind of values are present. So he knew that, and with that possibility, he just converted it. So you have to do some little bit of analysis yourself. You have to go through that CSV file and see what kind of values are there. And based on that, you will come up with some generic principles, and then you can convert it. This is not a very
Okay, we
effective
can
way.
do it series also, right? It is not that every one shot, one code.
No, 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 no.
We can do one step and then next step also we can
Yeah,
do
yeah,
it.
yeah, yeah, yeah,
So
yeah.
okay, thank you. And you can put a like you were doing previously. You can put a label for what we are doing
Yeah,
each
yeah.
and
I'm
every
putting
code.
labor. Yes. So that when you guys can see this notebook later on.
Yeah, notebook. Then we will forget. Seeing
Yeah.
the code without the what it is doing, it will be very difficult
I'm
to. Yeah.
trying. Okay, I'll just put like this. From here, main analysis has started. So I'll just put here. Um, Converted the total charges column, data type, from object to float. Yeah, float. Float. Now we will see the missing summary. Okay. So now it tells you that first of all, is null is a function that directly gets applied to data frame, and it will tell you for each of the column how many missing values are there. And then what I am doing is, this is just we are taking out the percentage. How we are getting the percentage? You see, yeah, it tells. Oh, it's very nice. Yeah, it tells you that based on the total length of the df clean, what is the length of the df clean? It is 7063. Whatever is the number, total number of rows, and based on the new, missing values, you will just get the missing percentage. Now, what I am saying is, I create a new data frame. In this data frame, I'll tell you what is the column missing value dot index. Index means where is this column actually located in my data frame. Data frame is what? 7063 into 21. 7063 is the rows, whatever is that number, and 21 columns are there. So I'm taking the 19th column. What is the missing count? So column is total charges. Index, from there I'm getting this. Missing count is how many values are missing. I got to know 11. Now you remember from where this 11 is coming? If you would have seen here that we saw that where it went.
Non-numeric counts.
Non-numeric. I don't know where it went. I just wrote it somewhere here. Wow. Oh, okay, okay. Now I have the, okay. So I'll just write it here. We had 11 values here. Okay. Yeah. And then what we am just printing this missing summary. Okay. So I got this. So I'll just write it down. We got the missing summary report for our data frame. Okay. So this part is clear. Next is missing tenure.
There is only one column having missing values.
I think so. There is one more, and just let me see where.
Why it is not listing in this? We are not getting
No,
a
no,
list here.
there is, yeah, because that another. So it is only counting for the numeric values. It goes and check if there is a numeric column. So from there it is getting this only one, because total charges we have already converted into float. There is one more problem here. I'll just see where it is. Let me see.
You are doing it on DF cleaned only, no?
Yeah, so
This missing value. So again, why total charges it is showing? It is already, we have handled that, no?
we have only handled the problem of conversion of object to integer. We have not handled the missing value yet. I told you here also
Okay,
that we
okay,
have just
okay.
converted it. We have not handled it. We are
Okay, we
going to
have just
handle it now.
changed the data type.
Hmm.
Okay.
Now we are going to handle it. Now I'm adding a new code that will handle it. Okay. So it is a bit of longer code is there. I'll copy it and then I'll explain you what. Just remove the extra lines and then I'll tell you how it is being. Missing values. Okay. We don't need this. We don't need this. Don't need this. Then you. Okay. We don't need these print statements. We don't need this also. And we don't need this. We don't need this. We don't need this also. Okay. Now it is a small, good looking. Okay. Yeah. So what I am doing is, see, missing value summary is greater than 0. Yes, it is greater than 0. I have one particular column. Yeah. And another question that somebody has asked, that it should give me any other data, any other column has null value. So it does not have. I've checked it. It does not have. Whatever this it is telling you, it is a good code. You can keep it handy in later whenever you are doing this analysis again. Okay. So it tells me that if the missing value is greater than 0, so yes, missing value, I found these missing values and these are my missing values. I know that. Okay. Now I know that only one this column is problematic column for me. So I'll say if total charges in missing summary column dot values. So yes, the total charges is a column for me. So what I have done, I have taken it sum. So now I know what is the sum. It is 11, right? Now we are coming up with this rule. Now these kind of rules, you have to specify them very carefully. This is a rule that sir has already specified. I'm just reiterating through it. So what he is saying, basically he's saying that you have to assess the customer on the basis of its arrival time. So from how much time in months this customer is with us. So as it seems that these 11 values where the total charges was missing, as it turns out, now this is a story. Okay, guys. Now this, what I'm speaking is a story. You have to come up with your own story with a new data set. Okay. So this is more of a business perspective, how you will look into it. Okay. Now, what I'm saying is, let's say my mean tenure. What is the tenure? This tenure is already given to me in my data set. Now, if the tenure is, it will give you what is the mean tenure. Okay. Now, if the tenure, it turns out that all those 11 customers where this total charges was missing, it turns out there were that they're missing like their tenure was less than 3. That they are less than 3 months old. So where there are very new customers. So what I'll say that fill my total charges on the basis of monthly charges itself. Did you understand this story? Whatever we have discussed right now, that if my missing tenure, my tenure is less than 3 months, that means my customer is relatively new, and therefore I don't have its value for total charges. And now, since I don't have the value for total charges, I'll come up with this rule that I have to fill those values with the help of monthly charges. Whatever monthly charges are there, just go and paste it to the total charges as well, only for those customers which are less than 3 months old. And there is an else block that tells you that if your customer is old, then you would have some total charges. Then whatever total charges are there, just take a median value and fill it with it. Now there are different things possible here. You could have done a mean value. You could have done a mode value, modal value, or you can come up with a constant also. Let's say I want to put a constant of 10 rupees. So you can do that. So these things are possible. So did everyone understand how we have handled the missing values here? Very good. Okay. Now I just run it, and you can see the mean tenure was 0 months. Now this clearly means that even this is just a customer that just came yesterday. Okay. So now since my customer is very new, I have used this rule. Okay. So I'm just writing it here. We have handled the missing value problem of this data set. I hope everyone is with me till here. Okay. 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 Moving to the next part. Okay. Now we are going to see what are outliers. Okay. So now the first thing, remember, you can specify an outlier for only the numerical column. It is very difficult to tell what is an outlier for a categorical column. So what I have done, I have taken the names of all my numerical columns, which are needed for me: tenure, monthly charges, and total charges. Now, if you remember, earlier one senior citizen was also there. Senior citizen is not needed. It is not important, that important for me when you are thinking of a churn data set. Okay. Now this is from a business perspective also, that which column is important for you, which is not important. You have to see through it. Okay. Now I have taken this total charges into account because I have already converted it. So what is an outlier summary? See, now you would have studied this in I think so MLF or Stats 2. So if you remember, you would remember how to calculate a 25th percentile, then median, that is the 50th percentile, and 75th percentile. There is, yeah. Now there is something known as IQR, interquartile range. The interquartile range is Q3 minus Q1. Q3 is your 75th percentile. You reduce the 25th percentile, that is your interquartile range. Now, with the interquartile range, you calculate your lower bound and your upper bound. So this is the formula, Q1 minus 1.5 times of IQR. IQR is your interquartile range, Q1 is your 25th percentile. Upper bound is Q3 plus 1.5 into IQR. Again, your Q3 is 75th percentile and IQR is interquartile range. Now, what I will say that in the entire column, if you find a value that is lower than the lower bound and value that is upper than the upper bound, for those values, though they will be counted as my outlier. So that's what I'm doing here. DF cleaned column is less than the lower bound or upper than or greater than the upper bound. Then I take its count and I convert it into a percentage. And what I'm doing, I'm created on another data frame just for my looking good purposes, that this is my column. This is how many outliers were found. What is the lower bound and what is the upper bound. Okay. Now I'll just print this. So nothing is outside. Okay. I think so. Very good. Okay. So outlier summary, formula to calculate outliers. Guys, everyone with me? Have you understood till this much part?
Yes, sir.
So can you scroll up a little bit?
Yeah.
Yeah, thank you.
You don't have to worry. I'll give you the notebook once this class is over. Okay. Okay. Now let's move to the next part. Okay. Now this is done. Okay. Standardizing. Yeah. Now we have to standardize the categorical values. If you remember, we saw earlier where it was. I think so. Yeah. Here it is. Yeah. You see, there was this problem of no internet service. Then we have this problem of no phone service. These things does not look good. You have to change them. Okay. So we'll do this now. This is all the everything comes under data processing. Okay. So data training, sir has explained very beautifully in the class. We are working on this part. Okay. Okay. I'll tell you one more thing. I will not run the code for you for that part here. I'll just tell you one more thing. There is one more section after this missing value thing that sir has done. We are not doing. He is just explaining it. I'll explain it. What does that mean? So what he is doing is that he's running the entire thing and he checks. See, there are some reality checks. Now, if you see, your payment cannot be, let's say, your salary cannot be negative. Okay. And your income tax will be in some slab only. It cannot be much higher than what it is expected to be. So there are some sanity checks called. But to keep the data realistic, we generally keep these rows. We don't remove them. But we should know that if there are some ambiguities in your data set. For now, I'm just keeping that part. There are some ambiguities in this data set, but to keep the things real, we will keep those rows. So there are approximately 21 rows where you will see your monthly charges is much more than your total charges of the year. So that means it is something wrong happening there. But for now, we will keep that. Okay. So yeah, now I'll move to standardizing your categorical values. Okay. Hmm. Check for common instances. Yeah. DF cleaned. DF cleaned. I'll see if another thing is required. And now after this, we will again do, once this is done, we'll again do df.shape. We need df clean.shape. Yeah.
Sir, even in even for deep learning, the data processing, pre-processing, and cleaning, this part is same as machine learning, right?
Yeah, everything, most of the things. Okay. So what we are doing is we are finding out all the categorical columns, and those categorical columns have a data type of object. If I tell that if there is a customer ID that has come up in the categorical columns, just remove it. After that, I have taken all the unique values. Now I know that there are something known as no phone service and no internet service. So for to keep the things consistent, what I am doing is I've converted I'm replacing no phone service with no and no internet service with no. So what you will get only standardized values like no and yes. So that then it will be easier for you to convert it using the label encoder. So there will be only two classes, 0 and 1, one corresponding to no and one corresponding to yes. Okay. So I'll just run this cell now. So gender, these things are there. So why it is happening? Because you print it here, and after that, if there is any phone service, anything was there, it got fixed. If you want to see, you can see this now. Okay. I'll just copy it into another cell, and I'll print this also because I want to see this. Yeah, you see, all your no internet service, those kind of problems are solved now. Now it has been brought it down to no, and your DF clean shape remains the same, 7043 into 20. So this was your entire part that belongs to this data quality assessment and little cleanup. So I'll take a 2 minutes break. Till then, you have any doubts, then please let me know. Yes, guys. Any doubts?
No
No.
doubts.
Okay. So this part is done. Next is now we move to exploratory data analysis. That is the main EDA, and what are the business insights that we get. Okay. So we'll start with that now. Just a new heading.
Sir, is the fashion dataset started?
No.
It will be after completion of this customer chain, right?
Yeah. And it will take a long time because it requires this also requires this analysis, and EDA part requires a lot of explaining to do. Yeah. So now we are on the EDA part. Okay. So we'll take a copy of this DF cleaned and we'll keep it. Okay. And we'll see what is the overall churn that is happening. Okay. So churn rate. So we know that the overall churn rate is 26.5%. What I have done, I've just converted this churn to yes, and we have converted into an integer. And with that, with the help of that, I've taken a mean value, this churn binary, and I'm putting these into a new, I've already taken a df underscore EDA, and we will use this df underscore EDA for the entire data analysis that we are going to do. Okay. And overall churn rate now I have is 26.5%. Okay. Now I have to find out what are the different types of churn rate possible by the demographics. Okay. So I'll take this code with me. We don't need these things. This is just to let you know that this first line is just we are creating a big plot of 20 cross 24, and now we will put four graphs into this. So one is that you are finding out for each gender what are the gender values, male and female. For that, what is the churn rate percentage? Then for the senior citizen, what is the churn percentage? If partner, I don't remember what were the unique values for partner. We'll see what it is. And what are the number of dependents? I think so. So I'll just run this. Yeah. So you can see a good looking graph has come in front of you. So churn rate by gender, churn rate. So you remember now we are looking only into this part of data set. Only your 26.5% is the churn rate, right? Now inside the 26.5%, how many male and how many female were there? So that is almost equal. By the age group, that is by citizenship, oh sorry, citizenship I'm saying, senior citizen, whether or not he or she is a senior citizen or not. So regular is 23% and senior is 41%. Then by partner status, whether or not the person has a partner, and churn rate by dependents, how if or not, like it is a binary kind of thing, whether you have a dependent person in your life, like somebody like your mother, father, or somebody is dependent on you or not. Okay. So we have got this table. We will see how, what are the things that we have to come up whether or not this is a problem or not. Okay. So now what we will do, we will find out service related analysis. So what is this? This is by the demographics. Churn rate on the basis of demographics. Next, we are going to
So
see.
this percentage, if I add, it should come up 100, right? No.
No. It cannot come, na, because it is only in the churn rate we are talking. It is not the entire data set. Your churn rate itself is very small.
Oh,
This,
okay.
these are all separate columns. The age,
Yeah.
partner status. These are all columns available in the
Yeah.
data set, right? Okay.
If you don't remember, just go above. You will see it is there. Okay.
Okay.
Yeah. Next is churn rate by the service related analysis. Okay. So we will do service related analysis now. So we are taking contract type, internet service, payment method, paperless bill. Okay. So I'll take this now and I'll just write something above. Churn rate by services provided. Okay. So this is on the basis of contracting. You see, you don't have to remember how these things have been plotted code for this, but you should understand. Once you understand, you will get it. Okay. So internet service, whether or not that person has internet service, then what is the payment method and what is whether or not he is doing the paperless bill. Okay, so I'll just run this. I don't know why it has become so small. I think so I have to give this again. Yeah, this looks good. Churn rate by contract type. So there are three types of people: month to month, those basis people, 1 year and 2 year people. So if you see, those people who are of 2 year contract, they tend to churn less. But those people who are on month to end month basis, they have high probability of getting churned up. Okay. Then on the basis of internet, so there are three types of people: DSL, fiber optics, and no people. Okay. And so this is what you get. Payment method, four types of things are possible: bank, credit card, electronic payment. I don't know what that means. And there is something called mail. Okay. So these four types of people. And finally, you have paperless billing. Whether or not that person has opted for paperless billing, churn rate on the basis of that. Okay. Now we have to see uh, how are numerical variables working against the churn data type. Okay. So I'll just bring this because I need to have the layout. Then only I can paste it. Yeah. And now I have to see tenure distribution, monthly charges, and total charges. Okay. Okay. Yeah. So you get a very good tenure distribution for the churn. These are the people who tend to get red are the number of people who get churned up. So if you see, if you are very new, then it is a high probability that you will get churned. But as long as and when you start going, like 60 months means 5 years, right? 70 months is almost 6 years. So churning after 6 years is less, but like those types of analysis you can cut. Then monthly charges, those who have very less monthly charges, they try to get retained, while those who have in the range of 70 to 120, they have a very high probability of getting churned. And then this is total charges. Okay. So these are the types of things you get. So I'll just write it down. Uh, Churn and not churn. You have both of the things, churn and not churn analysis on the basis of numerical columns. And what numerical columns that we are using is tenure, monthly charges, and total charges. So I will actually most important are the monthly and total charges. We'll see this later. Okay. 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 Next important thing that we need is a correlation heat map. Okay. So let's do that. Yeah. Oh, service count is not there. Why it is not there? Just give me a minute. Service count churn group by service count is not an index. Okay. No. Okay. Understood. My fault. Yeah. So what we have to first do, we have to introduce what are the service columns that are available to us. So what kind of services we are getting? Phone service, multiple line service, online security, online backup, device protection, tech support, streaming TV and streaming movies. So what I'm saying is we will create a new column known as service count is equal to 0. First of all, we do that. If for that person, if the service count is yes, then just add a value to it. So now what we are doing is we are trying to calculate this uh, correlation matrix for this. And I think so churn binary should be present already. Yeah, if you remember, we did churn binary somewhere above. Yeah, you see churn binary. Okay, just remember that. Okay, let's see this. We get that. So now we have churn binary. So your goal is for churn binary, how it is correlated to other of these columns. So it tells you that tenure, if the tenure is less, then it has more core, like, see, most of these have a negative correlation. That means If the values of this tenure, total charges and service count increases, then your churning will be more probable, right? And if your monthly charges and this monthly charges is directly correlated, and these are inversely correlated. You can see from here also, if your tenure is much longer, much lesser, then you will get churned out. If it is more, then you will get retained. So it has a negative correlation. That's why the values are in negative, and only monthly charges is positive. Monthly charges is positive. You see on this left side, more green persons are there, and on the right side, more red people are there. Okay, so this is the correlation matrix. Now we have got some general things, and last we need is um, customer life cycle. Okay, that is not important for us right now. Yeah, I think so. This much basic EDA should be enough for you. Yeah. So this is what we have discussed right now. Any doubts in this part? Then please let me know.
So one observation, the correlation is in the overall domain, but in some variables we can see it could be positive or negative depending on the subset of the domain. You need to be careful with that.
Yeah, true. Because sir has already seen and he has inferred on the data set. That's why we are using that. Otherwise, if you are using, yeah, this is for everyone. That if you are using a new thing, then first it is important to know which domain you are working in, and based on that only take decision whether it is a positive, negative, what kind of correlation happens. Yes. Anybody else having any doubts? Should I move to the next module now? Feature engineering.
Yeah, sure.
This is the major place where you play with the data. We have now understood the entire data set. Now you play with the data set. Okay, feature engineering means you make some new features, you remove the useless features if you think so, and based on that you take some decisions, and that will be your final decision. Means like building your first model, you have to take some harsh steps, you have to remove some columns, you have to keep some columns and those kind of stuff. So this is the place you will be doing that. Okay. Okay. So removing, we have done importing, loading, data quality, EDA, and now we are in the feature engineering part. Okay. So again, we will create okay. Prepare target variable. Extrain. Okay. Okay, so I'll create a new, so we have from df underscore cleaned, we are creating a new copy called df features. Just remember wherever you have created new copies, so you have to use the variables appropriately when you are doing the training time. Okay, so we have created something new, df features. Now we'll do our work in this df features only. So first thing that I'm going to do, we are going to create a customer life cycle stage based on the time, whatever is the tenure time. Okay. So what I'll say, I'll take this. Yeah. So we define a function known as get life cycle stage, and in this we take a variable called tenure. And if your tenure is less than equal to 12, we say that you are a new person and you belong to this new group of people. Tenure is approximately 12 months to 24, not equal to, it's because equal to 12. So you have to start from 13. So 13 to 24, that means you are growing. Tenure less than 48 means you are less than equal to 48 means you are matured now. And else you are if you are more than 4 years, then you are a loyal customer. So now I'm saying that I'll create a new column called life cycle stage, and from this tenure, I'll apply this entire thing and I'll keep this in this life cycle stage. Okay. So once you apply, you will get a new data frame. In this df underscore features, I have added a new column known as life cycle stage. Okay. So this part is done. Next is, if you want to know what is the revenue per month on the basis of, and on basis of that, you can give your customer a value score. Okay. So I'll just write it down what I'm doing here. Creating a new column called life cycle stage on the basis of your tenure. Okay. Next, what I'm doing is based on the total charges and on the whatever is the tenure, I can define what is the revenue per month. Okay, for that particular customer. So what you are doing here is you are calculating the revenue per month, calculating the revenue per month on the basis of total charges divided by your tenure time, and you get to assign a customer value score on the basis of that. Okay, so this is what we have done. Next, okay, I'm not running
One
this.
point here. Typically,
Yeah.
if it is insurance, your premiums are monthly premiums are constant. So many times, even the total revenue or lifetime value may be of more importance.
Yeah, that's possible. I would suggest, if you, because I also don't know much about this domain. I'm following what sir has already like given in the analysis. I'm just trying to explain it. But yeah, if you have the knowledge for that domain, please try it. If you have any doubts in perspective of code, then I can help you with that.
Sure,
I
sure.
don't have much
Okay.
domain
Okay.
knowledge.
No problem, sir. Yeah, continue, please. Yeah.
Okay. Next is next what we are doing is we are trying to create a service bundle score. Okay. So how, for that particular customer, what type of services that you avail? So what are the service features that we have defined as phone service, multiple lines, online security, and all these things. Then based on whether if your feature value for that particular feature is yes, then I have created a new thing called service bundle score. So I can give you a score for it. Let's say you are a customer and you have all of these things, then I give you a score of 8. Okay. And if you have only 3 of these things, I'll give you a score of 3. Okay. So in this way, I have created a something known as service bundle score. So I'll just write it down also. Calculating service bundle score on the basis of how many services that customer is availing, kind of thing. Okay. Yeah.
Puneet,
Yeah.
just I have one doubt.
Yeah.
See, now we are creating all this as a part of feature engineering. We have created 3 columns, additional columns, right? Based on
so
some
far, yes.
feature. Yeah, based on the number of months, based on the number of total charges and the tenure.
Yeah.
And this one. These columns, already we have a column, right? And then this is another column we create.
Yeah.
And these two will be already having some kind of interaction, right? Based on this
Yes.
form.
Yes.
Maybe positive or negative correlation will be there.
Yes.
So
Most likely.
how to decide this? Maybe you can give us an
Okay.
insight of
So
how to decide this feature. Okay, this needs a domain expertise. Of course, I can understand. But
see,
this
I'll
is a
tell
redundant.
you my
It's
own
creating a
experience.
redundant column, right?
No.
And how the
I'll tell
model
you.
will be behaving. It has already one column, and based on the redundant column, how the model. Can you just
Yeah.
throw some insight? Yeah.
Okay. So based on my
Leave
experience,
the domain part of it. Yeah.
yeah. So based on my experience, what I have seen, how companies are dealing with or like in Kaggle competitions where I have participated earlier, and on in companies how it is being done, that we don't know. Let's say I don't have a domain person also. I don't have a person who will tell me this or not. Okay. But if you see that in the entire data set, now playing with these things, whether this online security, now you see what I have done here is I have removed these redundant things. This is not redundant that I'm calculating the score. I am actually removing this redundant part. From a general knowledge, I know that these kind of service, these are simple services that a normal human being avails in our home. Yeah, just based on general knowledge. So what I'm doing is I'm just trying to collectively find out that how many services I'm availing as a customer, and I'm putting a score to it. Now what happens is if I have that score, I actually do not need this. There might be things like in this data
So
set,
ultimately, after having these new columns, you will remove the old ones. You mean to say?
if needed, most
If needed.
likely yes, but it depends. I don't know what sir has done, but actually you can remove this, and it will not affect your score differently.
Okay, because first iteration we will be not doing this, right? Feature engineering, first iteration we will run some
See,
score.
first iteration is very simple. Even if you see your MLP project, it is very simple. You just load your data set, just handle the missing values, and simply get a baseline score using a linear regression or your simple if it is a classification, just run a dummy classifier on that, and you will get your baseline score. Now, your final goal is to make your model as best as possible. Try to do best on your training data set, but obviously remember that you do not train it like 100% and your test data set, your answer is only 50% good. It should not be. There should be some trade-off. At least reach 95% in both of them. I'm speaking not realistically, but yeah, try to do that. So now you also don't know. Nobody knows what feature engineering I should do. But based on little bit of experience, you will soon see just participating 5 competitions, okay, on Kaggle, just for 5 months. Every 1 month there is one competition going on Kaggle. So just participate in them. You will see that you will not know how you will slowly going to realize that somehow I don't have its knowledge, but playing with fields, playing with different kind of columns, adding them, subtracting them, doing some meaningful business out of them, I am getting a better score. So this is what I have from my experience.
Trial and error only in that case.
Yeah, this is trial and error. This looks very
If you have
monotonic
domain
because
knowledge, you can play a little bit more, but
you can
otherwise,
play a good game with it if you have the domain knowledge. But if you don't have, then just play with your columns. That's all.
Okay,
If you don't understand anything, just multiply total charges with tenure. I don't know what it will become, but something will happen. And actually, it changes your score. Okay. So, yeah, that's what my take is on this topic.
Thank you.
Okay. Okay. So we have calculated this one. Okay. Next is what are the risk indicators? Okay. So now we will do that. Now what is being done here? That those things, if you remember our graphs, I don't know where our graphs was. Yeah. You see, churn by dependent. No means that there is a huge possibility that if you don't have any dependent, you might churn out. If you don't have a partner, you might again churn out. Then you see this fiber optic, very big percentage. If you have a fiber optic, I don't know why that person will churn out. If you are on a month basis, then there is a high chance that you will churn out. Then paperless billing. Now, if I am being churned out by that, then that means that this particular value for that feature is problematic for me. For contract month to month, internet, fiber optic, paperless billing, yes, partner, no, dependents, no. If these things are there, that means this particular user is on a very high risk of being churned out. So this is simple logic that I just gathered from my graphs that I created. Okay, so this is one part. I'll just remove it. So you have what you have done here. You have now found what are the values of the features that provide a high risk of being turned out. Okay, so this is done. In this way, yeah, there are some other things also. So I'll just take all of them now together. There are only 3 things left. Okay. Yeah. So this is a price sensitivity indicator. This tells you that if your monthly charges is for a particular user, if your monthly charges is outside the quartile range of 75th quartile range, then just show that for that particular person there is a high monthly charge. So he is above the, I'm not saying he's in the outlier. I'm clearly saying he's just having a high monthly charge, because we have already seen in our initial gathering that there is no outlier in this data set, and defining an outlier is not a vague thing. You have to go by the rule of interquartile range. From there only, that is a mathematical thing, you can't change it. Okay. Okay, next thing is you have created some interaction features. What you have done is you have taken a tenure and divided it by the monthly charges. So that gives you a tenure charges ratio. Then you have taken a monthly charges and divided by service bundle score. Now what happens? Now if you look in your personal life also, that let's say somebody is earning some 1 lakh rupees, then you have to give some amount to the services that you are availing. You take a mobile recharge, 1000 rupees for mobile recharge per month. Then you give Wi-Fi rupees, like 1000 rupees for Wi-Fi. Those kind of things. You have to give some amount of whatever you are earning. So whatever is my monthly charges, I divide it by my service bundle score. So that gives me what is the charge per service. If I am spending 1000 rupees out of 1 lakh, that means my percentage that goes is almost 1%, right? I think so. It is 1%. Yeah, 1%. But if you are paying 10,000 to, let's say, a maid, then your maid, this charges is 10%. So by that you get a charges per service, new column. Okay. And finally, you have a stability score. Now again, stability score is thing, I am using this rule, but actually it should not, like, this depends on you, how you want to define a person that is stable. Now, as per this, our rule says that if that person has a partner in life, if he or she has dependent on them, and if their contract is month to month, and if the tenure is more than 2 years, I call him a good, I call him that he has some stability in his life. So this is the rule that I am following. Okay. Yeah. So I think so. We have created all the features that Sir has stored. Now these are the new features with us. Okay. Now we move to next part, that we have to prepare our target variable. Okay. So I'll say that if my churn is yes, I'll convert it into an integer. Now I've created this target variable. Okay. Now I have to define my feature categories. Okay. So what are my categorical features? What are my numerical? And there are some binary features. Okay. So these are already defined by Sir. So I'm taking that. Categorical features are these, numerical and binary. So now you will see we are going to come up with a pipeline, that how you will send them across your model. These gets transformed into a certain kind of a data set that I want. And finally, I will send my entire data set for trade. Okay. Yeah. So this is done. Very good. Now we move to encode these things. Okay. And along with that, we will also do some this train test scripting. Okay. So we have the label encoder, standard scaler. So you just remember, I'll just write it down also. Label encoder is used for categorical variables, and the standard SS is for numcall. Okay, just remember standard scale. So there are some generally you will see label encoder and one hot encoder is used for categorical variables. There are, I think so, 3 kinds of things. Standard scaler, there are 3 scales. possible. So those are for the numerical values. And finally, we have train test script that we will use to split our data set. Okay. Okay. So we are using the DF features because here is what we have created these features in this all those features that we created right now, that is present here. So I've just put into a new data frame called DF encoded, and yeah. Now what I'll do, okay, this should be separate generally. Okay. Now I'll use my label. I'll convert everything into my label encoding. Okay. Okay. Yeah. So one hot encode features. Yeah. If there are multiple meaningful categories, for that I'm using this one hot encoding, and for normal binary like categorical features, I'm converting them using my label encode. Okay. This is done. Next is we have to create the feature matrix. Okay. We will drop the non-feature columns. Now, what are the non-feature columns? If you remember, we were multiple times saying that customer ID should not be there, and this churn is now not required. Okay. And what is my feature column? Feature column is everything, but not this target. So feature column, I'll get my entire features, and Y is my target. So the X and Y is just a standard way of saying you can say A and B also, but this is a good practice. Everyone uses this. Okay. Now finally, I will convert everything into my xtrain, xtest. So just remember, when I'm using X and Y here, so my X gets into two pieces, that is xtrain and xtest, and Y gets divided into two pieces, ytrain and ytest. And my test size is 0.2. So 80% of my data set, that is whatever number of rows were there, 7043 into 0.8, will go into xtrain, and others will go into xtest. And same goes for my ytrain, ytest also. And I'm using a random state. Random state is just equivalent to what I was earlier referring to as random seed. So in sklearn, you don't call it seed, you call it random state. And I'm using a stratify thing, that is y. What is y? Y is my target variable. Now what it will do, it will maintain the class distribution, that yes and no should be equally distributed. It should not be that your data gets trained on entirely yes data set and your entire thing goes into no. Then your model will not be a robust model. Okay. So we have converted this into xtrain, xtest. Okay. Next thing is you have to standardize these things. You have to standardize the numerical features. Right now, your numerical features are like haywire. So some has a maximum value of 1000, some have the maximum value of 10. So when I do the standard scaling, everything will fall into the line of 0 to 1. Okay. So I have applied the scaler. Yeah. So next thing is, now I'll fit this scaler on training data set right now. Okay. So I'll just fit it, fit underscore transform and transform. Okay. Numerical columns, xtest and xtrain. Okay. This part is done. Feature, yeah. Next is, now I want to know what is the feature importance. Now, based on what we have done so far, we will try to see which of my 25 or 26, I don't think so, I think so 30 features we have already. So based on that, what is the importance of them? Okay. So let's see this now. Okay. So now you see contract month to month has somehow the correlation with target as 40% approximately. Charges per service, stability score, tenure, these things have whatever feature importance this model is giving me right now. After transforming everything, this is how your feature importance looks like. Okay. And yeah, 1 minute. Next is you have to next part is very important. You have to handle the class imbalance. So let's see how it is being done. So we will use this from sklearn utils. class weight, compute the class weight. So I'm taking the unique values from ytrain. What is that? That is no and yes. And we compute the class weight on the strategy called balanced. I want the balanced stratification, and then I will put it into class weight dictionary. Okay. So now you see. So now it is better. Class 0, no churn is 0.68 and class 1 churn is 1.88. This is better than what we saw earlier. It was 2.8 is to 1, that is 3 is to 1. This is still 2 is to 1. Okay, this is better than before. Okay. Now, next we have to convert this entire tensor and prepare them for training. Okay. So we'll convert everything into a PyTorch tensor. Okay. So now just remember.
Is it 2 is to 0.68?
Yeah.
It's still same 2.8, right? Or 2.7?
Oh, yeah. It is still 3 is to 1, right?
Yeah.
Yeah, we are taken the certification here. Yeah, sorry, my mistake. Okay, just one thing you have to remember that you cannot directly grow from pandas to tensor. You have to first convert the pandas into a series into NumPy, and from NumPy you can directly go into tensor. Yeah, if you remember, we had discussed this in last class also. What is the process of moving from tensor to NumPy and NumPy to tensor? So you can refer to that. This is what is being done through this. Okay. And right now my device is CPU. So I think so. Yeah, that. Okay. It is saying the device is not defined. I just say device is equal to CPU. Yeah, it is now fine. Okay. So this is done. And
what is this device equal to CPU? What we are trying to do here?
yeah, so I think so you were not present in last class. So two types of devices you have. One is the CUDA, that is your NVIDIA GPU that is present and given to you in the collab, and generally people use NVIDIA thing. So this is the change runtime type. If you click on this T4, I am not doing it because my entire variables that I have defined will get deleted. Not deleted, but it will get means it is not present in my T4 GPU. No, it is saved in my CPU, right?
So it is suggested to use always CPU, or when to use this GPU?
Generally, text processing can be done on CPU, but even if you are doing text processing on the scale of millions and billions, then you have to use GPU. Image processing and audio processing should be mostly done on GPU only.
Okay.
Otherwise, your computer will most likely die.
What is in the GPU also? Many variants are there. What are those?
A100 GPU is considered one of the best. Right now, I don't know what is the maximum. I think so. Last in 8 months, I heard that A100 80 GB GPU is one of the best in the market. That is what my knowledge says. But there might be better versions available.
No, see only this. No, T4, L4, and A100 is best. What about
Yeah.
T4 and L4?
These are also given by T4. I think so. Is Tesla something GPU?
Okay,
It is also by Nvidia.
all
I think so. It is Tesla. Yeah.
GPU, all GPU by various OEMs. Okay.
Yeah.
What about this TPU?
TPU is another version of GPU. I don't know much about this because I have mostly never used it.
Okay.
But it is good for something. I don't know what that.
Okay, no problem. Let's proceed.
Maybe you can ask, remind me on this course. I'll answer this.
Yeah, sure. Let me first try myself to check it.
Okay. So yeah, now we have got the X-trained tensor, X-test tensor, and Y-trained Y-test tensors. Everything is ready with me. Just for keeping it for future, I'll keep this pre-processing objects separately so that I can use it later. Okay. So what I'm scaling, I've done a scalar. I've used a scalar. I've used label encoders. I've used my feature columns and class weight dictionary. We will see how this class weight dictionary, what the same 3:1 problem is there, how this will get resolved later. Yeah, okay. So I think so. These things are done. Okay. So yeah, one more last step is present. You have to save this. You have to save this class weight dictionary into a .pt file, and yeah, now this is done. If you see, it will show here. See, class weight.pt. Now this is clean. Whatever you wanted, I have mentioned here. Yes. So feature engineering is also complete. Hmm. Next part is neural network architecture. NN architecture building. Yeah. Yes, I think so. Yeah. Yeah. Any doubt so far in this part? In the feature engineering part? Should I move ahead? Guys?
This
Few minutes.
feature importance. Can we go to the
Hmm.
feature importance?
Feature importance. Yeah.
This one, the added, if we add, it's more than one, right?
Yeah, it will be more than one. It does not mean that it should add up to one. If you want to add up to one, you have to scale it. This only shows
Because we
this.
were having 21 and then you added some, so it will be more than 21. So this is the top 10.
Yeah.
Top 10. Okay, then there are some interactions.
Yeah, this is just showing that
Okay,
each individual feature, how it is related to and how it is affecting your target variable.
my
This
target.
is the target
There
variable.
are
Yeah.
interactions between them. Maybe they are all interacting. Still, we need to further
Yes, we have to
promote
further refine them. Yeah, yeah.
them. Okay, okay.
This is just one possible method. It is not the final method.
Okay, okay.
Yeah. Next is NN architecture building. Now we will build our architecture. I think so. This will be very easy should be for easy because we are just going to define a new thing, define a full end-to-end architecture for this, and we will run. So this is, I'll tell you what this is, learning rate scheduler. Okay, now I think so. Yesterday it would have been explained, and if you have seen the lectures, you would have seen what is this learning rate is. You guys know about what is learning rate? Can anybody tell me what is learning rate?
Step size.
Kind of. And how after each step, you are going to change this value of learning rate, that is alpha, and how it is going to, whether or not it will help you to converge, we have to see. So we are going to use this LR scheduler known as reduce learning rate on plateau. So this is a kind of a, like you saw now, for sklearn you saw a metric called ROCAUC score. That is a kind of a function that is already defined. So reduce LR on plateau means whenever you see a plateau, you reduce that learning rate. That is the kind of a function that I'm going to use here. Finally, we have this optim. Most probably it would be Adam optimizer, that most likely Sarah has used that only. We'll see later. Just run this once. Yeah. So now we have to define our class. Okay. We need diff init forward pass. Yeah. Okay. I'll just lessen this so that it looks neat. We don't need this. This you should know. Right now, you don't know right now these things. 8 initialization you should know, and Xavier Glorot initialization. Yeah. So what we are doing is we have we are defining a new module, and it comes from NN modules itself. We are defining a new class called churn predictor, and how I'm defining it is, we have an input size. We will see what the input size is. For training time, you can put a dropout, but don't use dropout in test during test. This might be one of your graded assignment questions. Then these are your layers.
Dropout rate?
Yeah, sorry.
What is this dropout rate?
Yeah, dropout rate is basically, see, when you are training a model now, so this means that every 10 samples, you drop 2 samples. So that your model does not start remembering the order of the samples that it came from. It should more focus on how the features are if influencing your target rather than starting remembering it or start to remember when which row came to me. It should not remember that. So for that we use dropout. Okay. Just remember that for test time you don't have to use this. And most likely this could be one of your graded PA questions. Don't know where it is.
Okay.
Yeah. Very important thing to remember. Okay. Yeah. So next is how you are defining a linear layer. First of all, we have a linear layer, and then you do the batch normalization. You apply a ReLU activation. Can anybody remember what does ReLU activation mean? What is the formula for the same?
Max of
0 to 0.
Very good. Hash is, A is equal to max of 0 comma AI. Okay. This is how does the ReLU function work. What are some different kind of ReLU different kind of activation functions that you have studied? Can anybody name this? So we have ReLU, GeLU, leaky ReLU. Sigmoid is there, then softmax is there. Softmax is also, yeah, it is a kind of activation function. TANH, very good, very good. So you should remember those things. Then you have a dropout thing. Then then you append these to an output layer. And since sigmoid will be applied in the loss function BCE, so you are not applying it here. Just remember, you are not applying the sigmoid here. You will apply this with the loss function. What is BCE? Binary cross entropy with logits loss. Okay. Now in this line is, and these lines are important because you have defined your layers, but these are not sequential. You have just defined it in the clouds. Okay, so there is one layer here, one here, something else there. You have defined those things, but to put them into a sequential order, you have to write that. So nn.sequential will put the entire thing one by one. Okay, so these things will be defined one by one. And finally, you initialize the weights. This will be random initialization, as you can see here also. Xavier and Glorot initialize. So this is a process. So you can do random. There are some other rules also. You can use those kind of rules. And based on that, you have initialized. And finally, you do a forward pass. What is forward pass? You take an input, you go through the one layer, then ReLU, then what have we defined? Yeah. Then first is input layer. Then you have the hidden layer. In the hidden layer, there is first is the linear layer. Then you have the batch normalization. Then you do this ReLU activation function. Then you perform the dropout, and finally you send it to the output layer. This is the forward pass. Okay. Yeah. So yeah. Subrat Tiwari, please tell.
Sir, I just wanted to ask this initialization, sir. Sir, is this taught in the lecture, or like will it be taught like later, or the different types of initialization?
No. You don't have to worry. Initialization is not you have to worry about. You can start with any place. Don't means it is generally advised don't start with 0, because if you start with 0, then it will take a long time to. So there are some kind of this pre-processed functions that are present to you, that Xavier and Glorot, whatever it is saying. So it will give you a kind of a boost you need, so that you reach your convergence easily. Okay. So that is only what this initialization process. You can start with a random value. np.run.rand also you can start with. That is not a problem.
Okay.
Only thing, you will require more number of steps to converge. Okay. But if you start with some proper good methodology, you will end up getting converged quickly. Yeah. The next is you want to see what is going to be your input size. So this will tell you what is your input size. Input size is 36 features you have. So yeah, Karthikeyan, you were saying 30. You have 36 features now. Okay. Yeah. So model. Now I define my model. This is my churn prediction. This is my hidden sizes and dropout rate. And finally, I will save it to my device. Next, I want to know how many number of parameters I have. Okay. So to know that, print 51585. I would suggest, I'm not giving much time on this. I would request you to see how, based on the hidden sizes and everything, how these parameters are calculated. Okay. So parameters are all those weights that you are training and the biases included. That is your entire model parameter. So just remember that. Okay. Now let's see how our model looks like.
This here, all this can be done by the library itself, right? We just give, we say model and then neural network and give the, like our other models, what we have done previously. We don't do this many steps, right? Or
Actually, see, it is very
we are too
easy.
much because these are all libraries can do it. All this, I feel these are all the pre-processing kind of a steps.
These are, see, building in a model architect. See, somebody in the first session had asked me, how will I ever learn whether or not will I be able to learn that how a model is built from scratch? To know that,
No,
you
that
should
can be
know.
abstract. We are already reading how the model is functioning as a
But if you
theory.
don't
These
code it,
things can be
even
abstract.
on a minimal scale, then you will never know how it is being done.
Because
What
we
kind of
don't do this for the logistic regression or other regressions or XG boost. We just take the model, give the data set, and then it gives the output. Yeah. So here we have to code a lot of things.
But I would suggest, I would say that this is good for, especially, I don't know how,
Okay, for
like, you might
understanding,
be a,
okay. For understanding, okay. As long as you understand how things function, and then it can be abstract. All these things.
see, for working professional nowadays, this could be a not important part for them. But especially for the freshers
Yeah, yeah. Okay.
who are
For
entering into
understanding,
the
okay. Yeah.
LLM world, you won't you in the exam, you like interviews, you don't get to directly call those libraries. You might have to train from scratch, at least for the interviews. Whether or not you will use it in the company, that is a different problem.
Okay. Okay.
For that purpose, you should know how this is being. So this is our network, how it looks like. We have a linear, batch norm, ReLU, then dropout. We have three hidden layers here. The linear, batch norm, ReLU, dropout. Again these things, and finally you have the output layer. Okay. So this is how our models looks like.
Can we plot this?
You are not audible, whosoever spoke. A lot of noise is coming from you.
Yes, I'm sorry about the background noise, sir. Can we plot this?
Can we plot this? Did he ask this only?
Yes, sir. I think he did.
Oh, so this is how it looks on plotting now. Like plotting, like could be, you can use Markdown language and try to plot it. But if you want to see how these layers are given to you, you can this model should be enough for you. But yeah, if you want a diagram, this is your diagram, something kind of this. You get a linear layer, then this will be your hidden layer, this will be your output layer. Then you apply a softmax over here. This thing you can build on your own. Okay. Yeah. Next is optimizer scheduler. We have to define these things. We have not yet defined. Okay. So now what we are doing is based on the class weight. If you remember, you had calculated the class weight imbalance. Now I've brought it back again and I've kept it into a specific tensor. And now I will use this binary cross entropy loss with Logit's loss as my criterion for punishing the wrong classification. Okay, for giving the penalty to the wrong classification. I'm using an Adam optimizer. Now, from where these parameters are coming? Because you have to optimize these parameters. Now, what are these parameters? These parameters are the weights and biases of my each and every layer. Okay, and my learning rate is, I'm starting from 0.0001 and I decay at the rate of 10 raised to power minus 5. Okay, that is my weight decay. So after certain number of steps, it will decay by this scale. And my learning rate scheduler is reduce LR on plateau. This optimizer, entire thing goes in here. My mode is minimum and factor is 0.5. I just half it. Okay. And my patience is 10. That means patience means how will you define that you have reached a plateau? If I see till 10 continuous points that I've reached a plateau, then I can say in this example that now I've seen 10 data points and they still form a plateau. Now, based on that, I can say that let's change my learning rate. So this is what is meant by the learning rate scheduler. Okay. Okay.
So what is weight decay?
Like how should I explain? Factor at which the learning rate reduces. I think so. That yeah, this should be the proper definition for weight decay. Okay. Yeah. So next is you have already done the training data. Now, if you remember earlier, we had only got the X-train and X-test. In generality, there is a good practice that your train data set should also be distributed into two portions. One should be your main training data set and one should be your validation data set. So finally, you will have three sets of the entire, three portions of the entire data set. So 60% will be available in your main training data set. 20% is for the validation and finally 20% can be used for testing. Okay. So this is the next part that we are going to do. Yeah. So you have increased the training. Yeah, this is X val set, X train split, X val set split, and X Y train. CPU, you are sending it to CPU, and again you are converting it into tensors. We don't need this. Yeah. Yes. So this is done. Finally, we now have to define the training epoch. Yeah, this is my train epoch. So this part, we don't need this, and backward pass. Okay, so what you are training on, you have a X train, you have your model, your Y train, optimizer and criterion has already been defined. For one epoch, what you will do, you will train your model, you will make sure that your optimizer has all the gradients as 0. If you don't have 0 gradients, it is quite possible that your model will not converge at the appropriate place. Okay. If you remember in the last session, we had seen what the squeeze function does. You backpropagate the loss and you optimize those weights and biases. Okay. So this is your train epoch. Similarly, you will have a validation epoch. So I'll just bring it. Yeah. Convert to predictions. Now at validation step, what you are doing, you have your predictions and you have your Y test also, right? So from there you can validate. Based on that, you can calculate the accuracy. Okay. So we have our validate epoch, and we have this training loop. Yeah. So these are my things. I will run this model for 500 epochs. I'll keep my best validation loss. Why I'll keep my best possible? So that even after 500 epochs, I just remember which is my best one. Okay. My patience limit at max is 25, but I've already defined it as 10. So it will get a range from 10 to 25. I'll keep the values. Test size is 80%. Usually it is 20%. Where? Huh. because this side is opposite now. So train should get 80% and 20% will go to the validation. Just a play of things. I hope that's
Okay.
clear. Training history, I'll keep these things: train losses, and validation accuracies. I think so. Now this model should run. If that is the case, let's see. Hmm. 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 Something should happen now. Yeah, we have to save the best model. Okay. Early stopping. Print progress not needed. Store metrics. You know that. What are the metrics we are doing? Rate, learning rate, validation, and training. Okay. So let's try this now. What happened? Optimizer is not defined. What? I defined the optimizer. Oh, we didn't run this. Yeah, optimizer is defined. I'll run this again. Epoch, validation epoch. Yeah, now my model is training. Early stopping triggered. Why it is early stopping triggered? Because my patience counter has already reached the patience limit. So I've already got my best model. I don't need to run this again. Okay. So now what I'll do, I'll just save this. Okay. So I think so we can stop at this place. We have kept it now. So in today's session, what we have seen today is, I'll just go back above once. Mm, yeah. So what today we saw for the customer churn prediction problem, we imported the main libraries, then we loaded the data set and found what are the initial insights. Then we went on to check the data quality and we did some little cleanup. Finally, we did a lot of exploratory data analysis and feature engineering. And finally, we built architecture, our own customized neural architecture for the calculation of this classification problem that we are trying to get. Okay. So this is at max we could do today. If I am not wrong, there are not much things left. Okay. So yeah, there are not much things left. You can the most of the things that was required for this customer churn prediction, I have tried to cover them as much as possible. I will share this recording as well as the notebook that we have done. I would request that all of you should go through it, and if you have any doubts, you can ask them on the Discord. And if you have doubts right now, you can.
Sir, the sheet, can you provide, sir?
What?
This file, sir, this file, can you provide this?
Yeah, that there is one discourse post that Pulkit has created now. So I'll just put it there. Both my session link, it has been recorded. I'll take that and I'll put this also. I'll download and I'll put that. Okay.
Okay,
Puneet,
sir, thank you.
this session is clashing with another course,
Which one?
TDS. It starts at 8 to 10, and yours starts at 9 to 11.
Yes,
So
sir.
is it
And my
possible?
also.
It's possible to shift it to Thursday. Thursday 6.
Actually, see, the main goal that was, see, I can't take before 9. It is problem for personal, like it is my personal problem.
No,
And
that is
Tuesday,
okay. If how
yeah,
about
I'll tell you.
Thursday?
Problem, what is the problem? Then some other course it will start clashing with. And we wanted that Wednesday is your deadline for the graded assignments. So you get your doubts cleared anything on Tuesday and Monday. So that was the reason why Monday and Tuesdays were set, especially for the TSS.
Graded assignment tomorrow is the deadline.
I don't know. You check. I don't know.
No,
So
on
the
5
deadline
October.
for week 1 is on 5th October.
Okay, then that is the deadline. Okay. I don't know why this was sent.
Sir, hello, sir.
Hmm.
What were you saying about interview? Like in the interview, we have to define everything.
Yeah. So I have went. Look, okay. So I'll stop the recording now. Is that fine?
Yeah,